All right, so I'm going to go through this video kind of quickly because today throughout we kind of went through a lot of these problems already. So you see me go through and discuss it, so it will be kind of quick. So for this one, adding radicals, we just see that our two radicals are exactly the same. And since they're identical, we can go ahead and add the numbers out front. So we have this 5, and it's understood that we have a 1 here because we have one of these square root 3's. So 5 plus 1 times the square root of 3, so it is 6 times the square root of 3. All right, that is it. All right, for this next one, we could look right away and say, oh, well, square root of 8 plus square root of 8, they are the exact same, so we can add the numbers out front. So 6 plus 4 will give me 10. However, just remember that whenever you are doing this, you are simplifying your radical completely. All right, so some people today in class, they left it as 10 times the square root of 8, but 8 can be reduced because I can rewrite 8 as 4 times 2. And I know the square root of 4. I know the square root of 4. And the square root of 4 gives me 2. So it becomes 10 times 2 times the square root of 2. And then this will give me a final answer. I'm going to write it over here as 20 times the square root of 2. All right, so for these ones, they're not the same. And so we can't add them right away like we just did. But we're going to look to see, can we simplify? I'm going to simplify them off to the side here so we don't run out of room. Well, I know that the square root of 108 can be broken down into 36 times 3. Right? And if you're not sure of this, you might have to just create a factor tree. But you're going to go through the paper. You will get it this time. And you'll go through and to see which perfect square goes into 108. And 36 does. And the square root of 36 is, now we'll look at them separately. The square root of 36 is equal to 6. So it becomes 4 times 6 times the square root of 3, or 24 times the square root of 3. For the next one, 2 times the square root of 75. Well, 25 is a perfect square that goes into 75. And 25 goes into it 3 times. All right, we can separate them, so it becomes 2 times the square root of 25 times the square root of 3. And that will then give me 2 times 5 times the square root of 3. And 2 times 5 is going to give me 10, so it becomes plus 10 times the square root of 3. Now we look and see, are these radicals the same? And if they are, we have to combine them. And yes, they are. So 24 plus 10 will give me 34 times the square root of 3. Final answer. All right, so for this problem, same thing. Look and see first, do we have any of our like radicals right away that we can combine? No, we don't. So we need to see, can we simplify them? Well, 2 times the square root of 80. Well, I know a perfect square that goes into 80 is 16. And 16 goes into it 5 times, so I can rewrite it as 16 times 5. And remember, if you chose the perfect square 4 instead, that's fine. You're just going to have to simplify that 20 later on. So you'd still ultimately get to the same answer. It's just going to take you a little bit longer. We separate these radicals. Well, the square root of 16 is 4, so 2 times 4 times the square root of 5. And that gives me 8 times the square root of 5. So I can rewrite this as 8 times the square root of 5. They're equivalent. They're the exact same value, is written in different ways. All right, the square root of 45. This one's a little bit easier. Let's just break this off. This one, we first look and say, okay, 9 goes into 45 5 times. Then we look at the square root of 9 times the square root of 5. And the square root of 9 is equal to 3. So this is just simply 3 times the square root of 5. So once again, these are the exact same value, just written in different ways. All right, so now for 216, hold on one second. I was going to erase this. I'm just going to move this over a little bit. So the square root of 216, so 2 times the square root of 216. Well, once again, if you're not sure what perfect square goes into it, you could start with 4, because 4 does. But then you'd have to just simplify this a few times. But 36 goes into it. We have learned cubes before, and 216 is 6 cubed. So that means 36 times 6 will give me 216. We separate them. And the square root of 36 is 6. So it becomes 2 times 6. And then this square root of 6 remains. And that will give me the final answer of 12 times the square root of 6. So now this gets written here, plus 12 times the square root of 6. Now we look and see, do we have any like radicals? If we do, we add them. Well, square root of 5 and square root of 5, they are the same. So we will add these together. 8 plus 3 is 11 times the square root of 5. And since this is just its own radical with no like terms, it just remains 12 times the square root of 6. And that is your final answer. All right, so let's get started on this one. I'm going to erase these as we go through them just because I don't have enough space. So 7 times the square root of 686. We did this one in class. So if you're not sure, you could create a factor tree and start thinking about what numbers divide evenly into 686. So here, I'll go through it. So you can do, all right, well, 2 goes into this. It goes into it 343 times. Then you can look here and say, all right, what number goes into 343? So the next number that you can say goes into it is 7, and 7 goes into it 49 times. So that means that we can break this apart of 49 times 2 times 7. And now we can look at these and say, all right, well, the square root of 49 times the square root of 14, since 2 and 7 are not perfect squares. And the square root of 49 is 7, so it becomes 7 times the square root of 14. So that then gives me 49 times the square root of 14. So these are equivalent. They are the exact same, just rewritten in different forms. All right, let me pause this and erase all this. All right, the next one is 6 times the square root of 200. Well, what perfect square goes into 200? 100 does. So it becomes 6 times 100 times 2. We break these apart. 6 times the square root of 100 times the square root of 2. And the square root of 100 is 10. So 6 times 10 times the square root of 2. That then gives me 60 times the square root of 2. So plus 60 times the square root of 2. Once again, we look here, 5 times the square root of 2. That can't be reduced, so it just remains 5 times the square root of 2. All right, now let me pause this and erase the work off to the right. All right, then the next one that we have to reduce is 5 times the square root of 128. Well, by now, this one is one that should be easy. 64 goes into it. We've done this multiple times. We break them apart. 5 times the square root of 64 times the square root of 2. Well, we know the square root of 64 is 8, so 5 times 8 times the square root of 2. And 5 times 8 we know is 40 times the square root of 2. So this is plus 40 times the square root of 2. All right, now we look and see, are any of these like radicals? All of these have the square root of 2, so we will add all of these together. Well, 60 plus 40 gives me 100, plus 5 gives me 105, so it's 105 times the square root of 2. And this is its own radical, so it just remains 49 times the square root of 14. And that is your final answer. All right, same thing for this one. I'm going to have to do the work off to the side, erase it. I did skip 200 because it was very simple. So just for interest of time, we're not going to go through it. So negative 3 times the square root of 28. Well, what perfect square goes into 28? 4 does. And how many times does 4 go into 28? 7. So then we separate them apart. Negative 3 times the square root of 4 times the square root of 7. Well, what is the square root of 4? That is 2. So negative 3 times 2 times the square root of 7. And that will then give me negative 6 times the square root of 7. So these are the exact same value, just written in different forms. All right, then the next one, minus 4 times the square root of 63. Well, what perfect square goes into 63? You guys should all know this by now. 9 does. All right, a lot of these we've done time and time again. And 9 times 7 gives me 63. We separate our radicals, so that way we can focus on them individually. And we ask ourselves, what is the square root of 9? That is 3. So it becomes negative 4 times 3 times the square root of 7. So that is negative 12 times the square root of 7. So this is minus 12 times the square root of 7. All right, then the last one is negative 3 times the square root of 32. Well, what perfect square goes into 32? 16. All right, if you did 4 times 8, that's fine, but you would have to then eventually reduce the 8. I'm just going to go straight to the largest perfect square. All right, then we go ahead and we separate them. Negative 3 times the square root of 16 times the square root of 2. Square root of 16 is 4. Negative 3 times 4 times the square root of 2. That then gives me negative 12 times the square root of 2. All right, then we look and see, do we have any like radicals? Square root of 7, square root of 7. So we would then combine those. Negative 6 minus 12 gives me negative 18 times the square root of 7. And since this one doesn't have any other like radicals, it just gets written as its own. So negative 12 times the square root of 2. Final answer. All right, so once again, you could right away and say, oh, look, I have the square root of 3 and the square root of 3. They are like terms, so I'm going to go ahead and add these together. So 4 plus 3 gives me 7 times the square root of 3. Perfectly fine. However, this square root of 48, we need to reduce. It's not the same, so we can't combine them, but we're going to look and see, can it reduce to be the same radical? Well, what perfect square goes into 48? By this point, we have done this time and time again. 16 does, 3 times. We separate them. Square root of 16 is 4, so it's negative 4 times the square root of 3. So this is now minus 4 times the square root of 3. Now we look and see, are they the same radical? Yes, these are exactly the same. So now we will combine the numbers out front. 7 minus 4, that gives me 3. So 3 times the square root of 3. And that is our final answer. All right, same thing. We look, they're not the same. So let's go ahead and reduce these off to the side. So 432, well, what perfect square goes into 432? 144 does. If you're not sure which ones go into it, then you're going to have to start just creating a factor tree and then looking for all of your factors together. But 144 goes into it 3 times. All right, and now we can look and see, do I know the perfect square of either of these? Yes, we know the perfect square of 143. So now the square root of 143 is 12, so it becomes 2 times 12 times the square root of 3, and that will then give me 24 times the square root of 3. So this reduces to 24 times the square root of 3. All right, now we'll look at the next one, minus 4 times the square root of 108. We've already done this one multiple times, so this then becomes 36 times 3. We can break these apart, negative 4 times the square root of 36 times the square root of 3. Well, this gives me negative 4 times 6 times the square root of 3. And we look and see, okay, this is minus 24 times the square root of 3. So now we look and see, do we have any like radicals? Yes, they're both square root of 3. Well, now we look, 24 minus 24, that is 0 times the square root of 3. But we would never write it like this, right? We simplify it as much as we can. So our final answer is simply just 0 because 0 times any number is 0. So you do not have to write 0 times the square root of 3. As a matter of fact, if we write it like that, you will lose a little bit of points because you're not simplifying it completely. All right, once again, I'm going to have to look at these individually off to the side and then just rewrite it underneath. So this gives me 4 times the square root of 108. We just literally did this one. So we know it's going to be 36 times 3. We know that we're going to then look at these separately. 36 times the square root of 3. The square root of 36 is 6, so it's going to be 4 times 6 times the square root of 3, which is then going to give me 24 times the square root of 3. All right, then the next one, it's minus 4 times the square root of 128. We did this one already in this video as well. We know 64 goes into it twice, so 64 times 2. We separate these, negative 4 times the square root of 64 times the square root of 2. Well, the square root of 64 is 8, so it's negative 4 times 8 times the square root of 2, which is then going to give me negative 32 times the square root of 2. Whoops. All right, so a lot of these radicals we've done so many times. So hopefully you just start to realize what perfect square goes into it. It's not really as much thinking that would have been done 2 weeks ago, because we've done so many of these. All right, the next one, we have 7 times the square root of 98. Well, 49 is a perfect square that goes into 98, and it goes into it 2 times. We separate them, so it would be 7 times the square root of 49 times the square root of 2. Square root of 49 is 7, so 7 times the square root of 2, which is then going to give me 49 times the square root of 2. So plus 49 times the square root of 2. All right, let's move on to the last one. All right, then this last one, it's minus 3 times the square root of 12. I'm going to go through this one really fast because we've done this a bunch of times. So it'll be 4 times 2. Well, the square root of 4 is 2, so it becomes negative 3 times 2 times that square root of 2, which is then going to give me negative 6 times the square root of 2. Then we look and see, do we have any like radicals? Well, all of these are square roots of 2. So we will combine all these. So that means this first one, 23 or 24 times the square root of 3, that will not change because there's no other root 3s. Oh, whoops. I'm sorry. Luckily, I caught this mistake right now. This is not root 2. I was rushing through this. Maybe I shouldn't have. So this is 4 times 3. This will be square root of 3. And this last one is square root of 3. All right, so now we look for like radicals. So we have these 2 square root of 2s. So let's combine these real quick. Negative 32 plus 49, that will give me a positive 17. So it's 17 times the square root of 2. And now these 2 are like radicals. So now we will combine these numbers out front. So 24 minus 6 is 18. So it'll be 18 times the square root of 3. All right, sorry for that one mistake. I guess maybe I shouldn't be rushing as much as I was trying to. All right, but that's it for this one. And then we're moving on to the last one, which is just distributing. All right, remember, when we're distributing, we need to distribute it into both. And we multiply our likes with our likes. So the whole numbers on the out front will multiply our coefficients with our coefficients, and then we'll multiply everything inside a radical. Well, when we just have the 4 here, and there's no other radical, it just gets rewritten as 4 times the square root of 5. Right? Then we need to distribute it here. So it's negative 2 times this 1, so it'll be minus 2. Square root of 5 times square root of 3, so we multiply what's on the inside, so 5 times 3, that gives me the square root of 15. We look and see, can we simplify these radicals at all? Nope, that's our final answer. All right, so first thing we do, we see we're distributing. We can distribute this into both. So then we get negative 5 times this 1, so it's negative 5. Then we look and see here, well, the square root of 30 times the square root of 3. We will multiply these two together. So 30 times 3 gives me the square root of 90. All right, then we distribute this in here. So it's negative 3 times 1, so it's minus 3. Same thing, we multiply our radicals. So 30 times 10, that will give me 300. All right, but now we need to look and see, can we reduce these at all? So negative 5 times the square root of 90. I'm sorry, I don't know why. Just the software right now is not picking up my writing very good, so it's very sloppy. So hopefully you guys can follow it. So negative 5 times the square root of 90. Well, what perfect square goes into 90? 9. So we rewrite it as 9 times 10. The square root of 9, we look at that individually. That's going to give me 3, so negative 5 times 3. And that will give me negative 15 times the square root of 10. All right, negative 5 times 3 is negative 15. All right, so let's look at the next one. The next one is negative 3 times the square root of 300. Well, we know the perfect square that goes into 300 is 100. And it's 100 times 3. Well, the square root of 100, we look at that separately. Square root of 100 is 10, so negative 3 times 10 times the square root of 3, and that gives me negative 30 times the square root of 3. So this is minus 30 times the square root of 3. Now we look and see, are these like terms? No, they're not. So then this is your final answer. All right, so for here, same thing. We're distributing it in. Well, the first thing we should see is it's negative 5 times negative 1, so it's going to give me a positive 5. And then we multiply on the inside 2 times 12, so that's going to give me a square root of 24. If you wanted to, you could have reduced that 12 first, but you didn't have to. Same thing, we distribute this in, so negative 5 times negative 1 is going to give me a positive 5. And then the square root of 2 times the square root of 3, we just multiply what's on the inside, and that will give me the square root of 6. All right, now we look and see, can any of these reduce? Yes, the square root of 24 can. So we look and see, well, what perfect square goes into 24? 4 does, and it goes into it 6 times. So we look at them separately, square root of 4 times the square root of 6, so it's 5 times 2, which is 10 times the square root of 6. All right, now we can say, are we finished? Not quite. We need to look and see, do we have any like radicals? Yes, they are exactly the same, so we can add them together. So we add the 5 and the 10, it gives me 15. So it is 15 times the square root of 6. All right, so same thing for this one. We're going to distribute it in. Now we'll multiply this negative 7 and this 5. That gives me negative 35. And then we're going to multiply what's on the inside of a radical. 10 times 30, that is going to give me 300. All right, now we'll distribute it into the next one. Negative 7 times negative 10 will give me a positive 70. And then 10 times 15 will give me 150. All right, now we'll look on the side and see, can these reduce? Can we simplify them? Negative square root of 35 times 300. Well, we know 100 goes into 300. So negative 35 times the square root of 100 times 3. We look at these separately. Well, the square root of 100 we know is 10. So negative 35 times 10 times the square root of 3 is negative 350 times the square root of 3. So I can rewrite this as negative 350 times the square root of 3. All right, now I'm going to do this one off to the left. So we will have 70 times the square root of 150. Well, I know 25 goes into 156 times. So 70 times the square root of 25 times 6. 70 times the square root of 25 times the square root of 6. This gives me 70 times 5 times the square root of 6. And 70 times 5 is 350 times the square root of 6. So plus 350 times the square root of 6. Final answer, because the two radicals are not identical. So there's nothing that we can combine. All right, last problem I'm going through. So remember, we're distributing. So we're going to multiply our likes with our likes. 7 times 3 gives me 21. Now, let's go through, before we do the square root of 60 times the square root of 60. If I give you square root of 2 times the square root of 2, we know this is a square root of 4, which is ultimately going to be 2. Square root of 3 times the square root of 3 is equal to the square root of 9, which we know is going to be 3. We talked about this in class multiple times. Square root of 4 times square root of 4 is square root of 16, which is then equal to 4. So that means square root of 5 times square root of 5, I know it's going to ultimately just going to give me 5 because it's going to end up being the square root of 5 squared. We did this multiple times. So the square root of 60 times the square root of 60 is just going to be 60. All right, on the test I just gave you guys, a lot of you guys made a mistake on that problem. You tried multiplying the numbers that were on the inside and got a really large number, and you made it harder for yourself. Just remember, when we multiply like radicals, that they are the same. We can just go ahead and take it out of the radical because it ends up being the square root of 60 squared, which is going to be 60. All right, and then 21 times 60 is going to give me 1,260. So that is already simplified, this part. So now we will distribute this in. This will give me 7 times negative 3, which is then going to be minus 21. And square root of 60 times square root of 20. Well, 6 times 2 gives me 12, and we add the 2 zeros. So now we just need to look and see, can we reduce this? Well, when I see it ends in 2 zeros, that I know that 100 goes into it. So I'm just going to break it out by 100 first. So it's 100 times 12. And it's going to give me negative 21 times the square root of 100 times the square root of 12. Well, I know the square root of 100 is 10, so negative 21 times 10. That is going to give me negative 210 times the square root of 12. Well, I know 4 goes into 12. So negative 210 times 4 times 3. Well, the square root of 4 is 2. So it's going to be negative 210 times 2 times the square root of 3, which is then going to give me negative 420 times the square root of 3. Then we look and see, are these like terms? Can I combine these at all? No, because this does not have a radical 3, so we just keep it as is. All right, that is it. That is it for this video. If you have any questions, message me on Remind.